Chapter 24, Gauss's Law. Here, uh, the aim of the objective of my study of this chapter is to calculate the value of the electric field E of the objects which are highly symmetric charge distributions. What I mean by this, these objects or the charges inside these objects must be distributed symmetrically. I can give you some examples about this kind of objects. Let's say here we have a sphere. Here we have a sphere. We can draw. This sphere is here inside. This sphere, the charges are symmetrically distributed inside. So the electric field, the emitted electric field must be symmetrically distributed, as you see here. So here we have the field E out of the object. In this case, we can use Gauss's law to calculate the value of this field. Okay. I can give you another example of an object symmetrically charged distribution. We can take a line of charge. What I mean, I have here a line. This line is positively charged and symmetrically. If we look from the top, if we have a top view, we can see the emission of the electric field here in this figure. You see here is the line from the top and the emission of the field in all directions, and we see that this emission is symmetric. So in this case, we can use Gauss's law to calculate the field. I can give also an example. We can say a plane of charge. This one is a plane here. This is a plane of charge, positively charged. So we get a emission, electric field emission on this side, to the right side and to the left side. Okay. So we have a symmetric emission of electric field. In this case, also we can use Gauss's law to calculate E. If you look from here to the object, lateral view, you can see the plane like this, which is positively charged, and the emission must be to the right and to the left. This electric field is symmetrically distributed on the object. If the object has a negative charge, so the field must be in the object, not out. So I give you 3 examples, and we want to talk about these examples in details later in the next videos. Also, the objective of Gauss's law is to study and to understand the properties of conductors in electrostatic equilibrium. Also, we talk about this point in the next videos. Uh, just if we have a simple example about an object which is not symmetrically charge distribution. For example, if we have a road like this, so here we get emission uh, on the road like this, okay, on the other side, on the three-dimension emission, but here you have like this, and here like this, and like this, like this, at this point like this. So here we don't have asymmetric. So in this case, we cannot use Gauss's law to calculate the field emitted by this object. I think now it's clear the definition of Gauss's law and for which object we can use this method to calculate the emitted electric field.